Assalamualaikum and a very good day to both the esteemed panels, Professor Madya Sir Muhammad Arif bin Mat Hanafiah and Technologist Sir Muhammad Azmi bin Said. I pray of good health to you both. First, let me reintroduce myself and my bachelor's degree project in which we'll indulge in a moment. My name is Muhammad Saudilai bin Muhammad Fikri from 4BEY Section 1/1. My supervisor for this project is none other than Datin Dr. Madam Fadzilah Binti Salim, and my co-supervisor is Madam Nurul Kausar Binti Abdul Majid, both of whom have helped me complete this project with their guidance. My project is entitled Development of Alcohol Detection System with Vehicle Immobilization and Internet of Things. Drunk driving has been a problem in our society for years in which have claimed the lives of many. Thus, I have developed this project to keep drunk driver at bay by preventing them from driving in the first place by utilizing an alcohol breath test to determine whether the user is eligible to drive or not. If the user passes the breath test, then the vehicle ignition will unlock and enable them to insert the key to the vehicle to start it. On the other hand, if the result exceeded the limit set in the system will lock the ignition, preventing a potential drunk driver from driving the vehicle, and a notification will be sent to a guardian registered in the system to inform them of the situation and their location in real time. The objectives of this project is to first design an alcohol system with vehicle locking capabilities based on two microcontrollers, which is the Arduino Uno and the Node MCU. Second, to develop the design made with functions such as measuring estimated blood alcohol content using the MQ3 alcohol gas sensor and real-time vehicle tracking using a GPS module and Blink application. Lastly, the objective is to evaluate the prototype for its effectiveness in preventing drunk driving. I have researched past projects which are related to this project and made a design with those projects as its basis. The circuit diagram in Figure 1 is what I have designed, and I procured the necessary components to assemble the final project prototype in Figure 2. Next, I needed to test the MQ3 alcohol gas sensor, to which I tested the sensor with 3 different alcohol concentrations, which can be found commonly in alcohol drinks sold at any convenience store. The gas sensor was tested under 2 conditions. First was the gas sensor was placed directly above the alcohol substance. The second condition was I placed the gas sensor 3 centimeters away from the alcohol substance to simulate the detection of alcohol vapor in the air and the gas sensor alcohol detecting capability. The results of the experiment can be seen in Table 1 for the first condition and Table 2 for the second condition. Not only that, I have developed a real-time vehicle tracking and alcohol level monitoring function through the use of the application Blink. When drunk drivers are detected, the app will notify a registered guardian whose phone has installed the app and inform the user of the vehicle's location to send help, as can be seen in Figure 3 of the poster. In conclusion, the project in which I have developed are able to estimate the blood alcohol content, alert users of drunk drivers, real-time vehicle tracking, and vehicle immobilization. The 3 objectives that I had mentioned in the beginning are satisfied. I shall now demonstrate the functions of my project. Firstly, the vehicle is locked by the servo motor located at the vehicle's ignition. The user will need to test their breath to determine whether they are eligible to drive a vehicle or not, and to unlock the vehicle's ignition. Prior to running the breath test, the system will warm up the MQ3 alcohol gas sensor, then proceeds to be in standby mode, which means it is ready for the user to test their breath. In this case, I tested the system without the presence of alcohol, hence the system will unlock the ignition for me and enable me to insert my car key into the ignition to start it. The user will need to blow into the flow sensor to enable the alcohol sensor to start taking a reading of the user's breath. The flow sensor function is to not allow the MQ3 alcohol sensor to constantly taking a reading as it will produce a false breath test result. Hence, the flow sensor is to make sure that the user is blowing into the sensor. The flow sensor and the alcohol sensor are combined into one device, so their function complements each other. Next is a situation where the user is supposedly drunk. I use a hand sanitizer to simulate the high concentration of alcohol vapor in the user's mouth before blowing into the breath analyzer I have fabricated. The law in Malaysia states that only under 0.05% of blood alcohol content is allowed to drive, although it is highly advised to not drink any alcohol substance before driving. Back to the matter at hand, when I blow into the breath analyzer, the system detected a high concentration of alcohol, which registered in the system is above 120 parts per million or ppm, or equivalent to 0.05% of blood alcohol content. Thus, the system does not unlock the vehicle ignition for me. When the alcohol level reading exceeds the permissible limit, the Blink application will notify through the user's Guardian smartphone where the application is installed. In the application, the user can track the vehicle's location in real time and monitor the alcohol level reading. This way, the user can send help immediately to the location to prevent any further incident to occur. As you can see on the screen now, this is how the interface of the Blink application works, where you can check the real-time location of the vehicle and when the alcohol level reaches or went over 120 ppm. The Blink app will send a notification to alert the user of the situation. All in all, this project has a multitude of novelties in which it can detect alcohol presence, vehicle immobilization, real-time vehicle tracking, and alcohol level monitoring. I have also designed this project to be plug and play, then ultimately to be user-friendly. The cost estimation of this project that I have developed is at 165 ringgit 29 cents, which in my opinion is quite cheap considering lives are at stake. That is all for my project demonstration and bachelor's degree project presentation. Thank you for listening and I look forward to the Q&A session.